0 views, it'll be awesome. All right.
We start vlogging.
So, we determined that this was alpha because parallel lines cut by transversal. These two angles have to be congruent.
Yep.
So this would be 90 minus alpha, which left alpha for that one. All right, so I'm going to erase some of that stuff so it doesn't get in our way. That was not as important, but getting there was important. Okay. Now, I did hear in this class that cosine of alpha plus beta is this length here.
No.
No, it's the full length. It's to H. All the way to H.
Is it? Yeah, it is. Yeah, it is.
No, it isn't. Then I misheard. Because if we look, here's my right triangle that I'm using to make that statement. And if the hypotenuse is 1, then CI is the cosine of alpha plus beta.
We assume that.
Okay? So we know that this is CI.
Well, I did this wrong.
Okay? So that's where we're going to start. Guys, I need you paying attention.
Sorry.
All right. Now, we need... No, we can do this. What is CG?
This is
Cosine
cosine or
Cosine of beta, okay. All right. What would GE be?
Sine beta.
Sine beta. Okay. Sine of beta is GE. So what would FG be?
FG? You
Uh,
said FG?
Yeah.
That's sine
It'll
of
be
sine
sine of
of
alpha.
alpha.
Or what's that one number?
No, it'd be close to FG.
No, sine of alpha times sine of beta.
Okay, so if we set this ratio up, we know that sine of alpha is equal to opposite FG over hypotenuse, which we just determined was sine of beta.
Boom. Told you.
So he's correct. FG, this segment right here, is sine of alpha times sine of beta. Right? Okay, this is a rectangle. So if FG is sine alpha sine beta, what is IH?
Sine alpha.
Sine alpha sine beta.
Beta and alpha.
Okay, now, my goal is to have CI. Right now I have IH. If I could find CH, could I just take that little part away and be left with what I need?
Maybe cosine.
Okay.
Are we assuming that like CH is a straight line?
I did this.
That we don't have to assume that because we can tell how it's drawn that it is a line. Yep.
Okay, so if angle I is 90 degrees, can we also assume that D is 90 degrees?
Where's D?
In the top.
No, because it said that is a quadrilateral.
But you just
So
said
it's
if
not
I
square.
is 90 degrees, then you can assume that D is 90 degrees.
This stated it was a rectangle. That's why I knew all those were 90. Now I know this one's 90 because it forms a linear pair with this. So these two angles have to be supplementary. So that's why I knew this was 90.
But you know that that's a straight line.
This is a straight line,
How
yes.
do you know? What if it's like buried just a little bit?
Stop being difficult.
So like, if it's slanted, then that wouldn't be a rectangle.
Because it wouldn't be
Yeah, I mean, it
90.
could be. I see it could be going down a little bit.
It wouldn't be a right triangle, right?
Okay. Let's move forward. All right. So, let's see if we can deal with cosine of alpha right here for a second. If I did cosine of alpha, is there,
Cosine of alpha is 90 beta.
what is it?
Cosine of alpha.
It would be the adjacent, right? CH over the hypotenuse, which is, yeah, cosine of B.
So you subtract.
So CH is cosine alpha
Times cosine beta.
times cosine beta.
And this subtract sine.
Well, why would you need us?
Okay, so what we said was to find that CI, which we started with, we knew that CI could be CH minus IH, which we just saw for CH. It is cosine alpha cosine beta. Minus IH, which was sine alpha
Times sine beta.
times sine beta.
And then we should
Now,
get-
this is the sum formula for cosine. That's it.
What was the bottom?
The bottom was this. Okay, so this is basically using a geometric proof. To find our sum formula for cosine.
I got half of it.
Got it.
I just forgot to subtract the side.
Oh, that's pretty good. Pretty good.
Are you serious?
That's
Okay,
very-
at the end of today's lesson, if any of you guys had questions about last night's homework, I will answer those individually or collectively if we all have the same question. But right now, I'd like to go ahead and do today's lesson. That way, those people that didn't have any questions can move on with tonight's homework when I'm done, okay? All right. So we just developed our first sum formula. Whoops. So this is a sum formula with cosine. So we found that cosine we could do alpha beta, we could do U and V. Most textbooks will use U and V. Let me see what your textbook uses.
U and D.
Probably U and V.
Why don't they use, like,
They do. They use U and V.
Take notes on this and Robson.
I would. We're going to talk about 4 formulas today that you just need to know. These are need to knows.
why don't they use O and A for opposite and adjacent? Doesn't that make more sense?
Why you gotta make it
Okay, so what we just discovered is cosine of the sum of 2 angles can be found by doing cosine of the first times cosine of the second minus sine of the first times sine of the second.
Oh, we just established that.
We just did. Yeah. So how is this helpful? This is our first formula. There's going to be 4 of them, but this is our first one. So if I ask you on the next no calculator quiz what the cosine of 75 is, which it won't be on tomorrow's quiz, right? The new stuff, not tomorrow. But on your test, when I ask you cosine of 75, whoa,
Cosine of
That
45
is-
plus 30.
that's right. This is not one we know, but we do know cosine of 30, and we do know cosine of 45. Okay, so what we would do is cosine of the first times cosine of the second minus sine of the first times sine of the second. This is where you're thankful you know your unit circle. Okay, so cosine of 30 is what?
3 pi, 1 pi, 1 over 1.
It's root 3 pi over.
No, he said
No, it's
root
3 root 3 over 2.
Root 3 over 2. Alright, cosine of 45. 1 over the square root of 2.
That's where it's 1/2.
Okay, sine of 30 is 1/2. And sine of 45 is 1 over root 2.
I was that.
Okay, so what this gives us is root 3 minus 1 over 2 roots of 2. Now, some of you actually learned this as root 2 over 2. Is there anybody in this class that always writes root 2 over 2? There isn't? Okay. So if you write root 2 over 2, your answer is going to look like this. It's also correct. It's the same.
Yeah.
You'll just have a rationalized answer.
Yeah.
So So these are equivalent, and so you're good.
Is that it? Is that all you write for the answer?
That is the answer, yes.
Okay.
Okay.
Yeah, I thought they were,
It seems easy for
that
now.
would be good.
All right. So that is a sum. Now let's do a difference. So the difference for cosine
Oh, happy.
is just going to change my sign here.
Wait, it's just.
So it becomes cosine of the first times cosine of the second plus sine of the first times sine of the
So it's
second.
just backwards, basically.
It is backwards.
kind of weird.
Cosine is backwards. We start with cosine, we end with sine.
And so in this case, if we're, say they're like,
This
is
is
there any angle measures like
Mhm.
that we would?
So-
So I'm gonna guess the sine of the.
We could do the same thing if I ask you for cosine of 15 degrees. I mean, we were using the exact same things, but this time we would, switch them. We would just subtract. We're not doing that, but we could. Okay, instead of asking you for a cosine of 15, what if I ask you for something strange? Like cosine of pi over 12.
Yeah, we're screwed. But also, I'm sorry, but on cosine of 15, it says 45 minus 15.
Oh, it should be 45 minus 30.
Sorry.
Hold on. 4 minus pi over 6
It
metric.
is.
But the reason why you use those is because you know what those are. You don't know what 15 degrees is.
I don't know. Cosine of pi.
Or like negative.
All right, so some of these I get are a little tricky. I know what they are just because I've had once you have enough experience with them, you're going to be like, oh, I know what to do. But it may take a minute. If it takes a minute, you could always convert this into degrees.
Oh.
What is pi over 12 in degrees? It's 15 degrees.
Oh.
So these are the exact same problem. So you would do cosine of pi over 4 minus pi over 6.
Where do you?
Okay? So if I give it to you in radians and you don't see it, like if I ask you for cosine of 7 pi over 12, you might see it. Does anybody see it? Okay. All right, we'll do that with sine.
Pi over 4
Pi over
plus
4 plus-
pi over 3.
It would be 105 degrees.
It would be pi over 4 plus pi over 3.
105. I'm still.
I'm just confused on where you got 15 degrees from pi over 4.
Because they need to
From
make the
pi
base.
over 12?
That's it.
Okay, so to convert radians to degrees,
Oh my god.
okay? We know that 180 over pi x over pi over 12. You can cross multiply and solve.
Oh, that same.
You might be able to just look at it and go, this is 180 divided by 12.
Which would be 15?
Yep, 15. These were the same.
Which would be.
Yep.
That's smart.
Now in my head.
Or we already established it.
Well, if we had a question,
You don't have to kill my mind, guys.
All right.
You don't have a 5.
Okay, so that's cosine.
You must have negative 5.
This is our sum formula for cosine. This is our difference formula for cosine. Now we're going to look at sine. And yeah, we could prove all of these.
Wait, can I guess what sine is?
I can do it.
Yeah.
It's sine times
16.
sine of the
Cosine
Sine's
is
a little
A
different.
second. Is it division?
We'll do a sum. Okay, so this is where we do sine of the first times cosine of the second.
I'll just say SUV.
That's what I was about to say.
And then
Plus second.
Plus
times
what?
Sine of the second times sine of the first.
Cosine.
cosine of the first and sine of the
So it just
second.
flip flops.
A lot of
They're not flip flops.
It is flip-flops.
It's not keep it, change it, flip it out.
No, it's
Oh my
flip
god.
flop.
We don't want to
It's
set it
multiplied by
right.
the reciprocal column.
Flip flops are things that line.
All right. And now we'll do a difference. Yes, ma'am.
Is there a reason that you do the like different V on each side of the equation? Or like are they the same? Okay. I wasn't sure.
No, just me being a little sloppy right there. Okay, so this one's very similar. It's sine of the first times cosine of the second. And what do you think the sign's going to be right here?
Cosine
Subtraction.
first over sine of the-
And then cosine of the first,
Nice
Uh,
sine of the second.
sine of the second.
I don't like the first
Will be.
one. You
I have a
say U and V.
Yes.
Does it matter if you flip it around? If cosine times sine comes first, minus sine times cosine?
So,
It's,
okay.
yeah, multiplication is commutative.
So, yeah, I was saying, because like identity.
Yes.
What are you in
Okay,
fourth
so yeah, I
grade?
might have missed like when you said this, but like when will we use this kind of stuff?
One, we're going to use it in proofs. Two, we're going to use it to find angle measures that you don't know. Like,
These
right
two?
now, we're going to find sine of 7 pi over 12.
With using these two. that-
Yep, using these formulas without a calculator.
Okay.
Okay? So, how can we break up 7 pi over 12? We already talked about this with cosine, so it shouldn't be that hard.
You can break it up in.
We just did.
Pi over 3, plus or minus,
Yeah.
plus pi over 4.
You got problems?
So how do you know this one?
Okay, so now we're using a sum. So what we do is sine of the first times cosine of the second plus cosine of the first times sine of the second. So what is sine of pi over 3?
1/2.
1/2. Cosine of pi over 4?
1 over root 2.
1 over root 2. Plus cosine.
Root 3 over 2.
Y'all are backwards.
Yeah,
This is root 3 over 2, and this is 1/2. Yeah, I was just going with it.
Oh, wait, yeah, yeah.
Well,
Like-
that's Carson's fault.
All right.
It's a brick.
And then sine of pi over 4 is
1 over root 2.
1 over root 2.
Freaking brick.
So this is root 3 plus 1 over 2 roots of 2. Now, that is very similar to the answer we got just a second ago.
Right.
You're going to see a lot of similarities because we are going to keep using things that are on the unit circle. And they're all very similar. Okay? So you're going to see some similarities. Some repetitions of things will pop up over and over again. Some will be some will be differences. Yes, sir.
Wait, how'd you simplify that again?
Um,
No, I mean the root 3 plus 1.
You can do subtraction if you want,
I multiplied these two.
as long as it makes them.
And when you multiply those, you multiply straight across. So you get root 3 over 2 roots of 2. I multiplied these. So you get 1 over 2 roots of 2. And then because they had a common denominator, I wrote it with a common denominator.
Sure. It's just
Wait, but didn't you?
depends on how you do it.
Oh wait, that was plus
I woke
the
up this
last
morning, I
one.
had to go back to sleep. It was like 6.
Yes, Edwards.
Okay, so what if it was negative 7 over 12? Would we just solve for 5 over 12 then?
If it was negative 7 pi over 12, what would you want to do?
Would you like, instead of like finding negative 7 pi over 12, would you just go find the opposite and find 5 pi over 12? I was wondering how it worked.
What?
If it was like, if it was negative 7 pi over 12, would it be like over
I would do some subtraction so that it ended up being negative. Alright. The next thing I want to talk about is tangent. So we also have tangent sum and difference. So the sum of two angles. And tangent looks a little different. So it looks like this. When we have a sum, we have tangent of the first plus tangent of the second. But then it's over 1 minus tangent of the first, tangent of the second.
This is the sum, right?
Now when we have a difference of two angles,
Sorry.
You don't know.
We're just going to switch some signs up. We'll have tangent of the first minus tangent of the second. Over 1, what do you think it's going to be? Plus tan first times tan second.
Special term of
Wait, what is this? All roots or what?
These are sum and difference formulas. Our trig, sum, and difference formulas. So we're doing that today. We'll practice some more tomorrow after your little short proof checkup. And then next week we will do double angles. So we are moving right along with our trig. All right, so those are our 3 sum and difference formulas. So we have sine, cosine, and we just did tangent. All right, you use them all the same way. Okay. Now
for the reciprocals.
No.
I'm kidding.
No.
Don't say that.
No. I'm going to ask you what you think this is equivalent to. Cosine of 40 times cosine of 15 minus sine of 40 sine of 15. Is this a sum, difference? Am I using cosine, sine, or tangent? Which one is it?
Cosine.
It's
Cosine is 75.
It's a sum with cosine, so what would the answer be?
Cosine 55.
Very good.
Oh, I was. Oh, good
I
at it.
solve it.
How do you do that?
I'm dumb.
Okay, so you look at the pattern.
Right.
So it's cosine, cosine minus sine, sine. So which one of these did cosine, cosine minus sine, sine? That's a sum with cosine. Okay, so what you do is you take the 2 angles
And add them.
and just write it as cosine of 40 plus 15, and that yields cosine of 55. Okay, so does that make sense?
Yeah.
All right, now we're going to do where I give you like a identity and we're going to prove it. Okay? So, let's say we have cosine of pi over 2 minus x, and we're going to prove that it's equal to sine of x.
Oh.
Wait, the parentheses are
That parentheses is just extra.
I see.
Yeah, just being extra.
Wait, what?
All right, so this is a difference. So I'm going to use the difference formula for cosine on this side. So it would be cosine of
The first. Pi over 2.
pi over 2
Cosine.
times
Cosine x.
cosine
Wait, yeah.
of x.
Minus. No,
Oh, hold on.
Plus.
A difference is plus
Sine of
sine of
1/2.
pi over 2
Jesus.
times sine of x. Okay?
And it's just 1/2.
Now, what is cosine of pi over 2?
1 over 2. Oh, wait.
0.
0.
0 plus 0 is 0.
What is sine of pi over 2?
1.
1.
Ah, okay.
So do you see we just proved?
They just proved what it looks like on the ground.
Okay, so we did a proof of a co-function identity that we had already studied. Do y'all remember studying this?
Yes.
Yeah, the 90 minus x, we said, or pi over 2 minus x.
Cosine x.
So that's a proof.
So, what if you can't do it?
What if you, oh, you can prove it. You can do it. All right, let's see if there's anything else I need to go over before we set you free.
What you got in your mouth there, Edward?
Nuts. Nuts. We're not learning how to do reciprocals with these too?
You're going to do quite a few proving identities, and then you're going to use the formulas. So I think we've done enough for today. I'm going to quit recording here, but remember, now I'm checking homework, and I'm answering any questions over last night's homework.
Is tonight's homework on this or on review for tomorrow?
Tonight's homework is on this.
So we're done.